We're now going to do the same thing, but start with something we've never graphed before, a square root of a parabola. Any ideas what the equation of this parabola is just by looking at it? It'll be a positive one because it's going up, right? Its vertex is at 3, -4, so that would show up as x plus 3 squared minus 4. Would there be an a value in front? Nope, because we go over 1, up 1, over 1, up 3. It matches up with the regular graph. So now in blue, we're going to graph this. Okay, exciting. So we're going to go through those same steps that we listed last time. If it's a square root graph, a cube graph, a log graph, those steps for graphing, if you have one graph already done, then to graph the square root of it, you just have to go through the process and say, are my y values ever 0? Do I have any x-intercepts? Yes, I do. I have one here. I have one here. Are my y values on my original graph ever equal to 1? Yes. They're not at nice points. Would you agree that here and here is where they're equal to 1? I have no idea what my x-coordinate is right there. I mean, algebraically, I could plug in 1 for y and try to figure it out, but I don't want to. But those would be our 2 points. Do we have any other nice points? Not really. I mean, can you see that here my y value is 4? So if I went and I square rooted that, that means directly below it is where my y value would be 2, because the square root of 4 is 2. And same thing on this side. I could do that. But I don't really have a lot of nice points to work with. And finally, just like before, between 0 and 1, you need to show it slightly above. And this is one, it's going to be really hard to do that. And then after y equals 1, you're going to show that it's below. Now, showing that it's below is pretty easy. But showing that it's above in this little part, without going back in time, it may look just like that, like it's almost on top of the graph. As long as you never have it go below, because as soon as it goes below, they'll be like, nope, they made a mistake with that. But in this case, it's very hard to show it above without over-exaggerating, and over-exaggerating will also lose you half a mark. So in this case, it is just slightly above it, or maybe right on top of it. That would be considered fine. Domain and range. The domain in this one's a little bit different, because we have everything from -infinity up to 1, but then we're missing stuff in between, and then it starts again from 5 and goes on forever. So how do we write that? We can say x is less than or equal to 1, or x is bigger than or equal to 5. So we write both sections separately, and we write the word or in between. In interval notation, I'll do interval notation for this one. You'd start at -infinity, and you'd include everything up till 1. And then you'd start again at 5 and keep going up to +infinity. And in between, in interval notation, we make this big U. That U stands for union because it's this one or this one. I just say it's this one or this one, and then I remember it needs to be a U. I don't know if that's helpful. So that's how you would write it in interval notation. And our range, well, our range is just y is bigger than or equal to 0. Don't write this down. Can you see yourself being tempted to do this? Oh, if I had this equation, y equals the square root of x plus 3 squared minus 4, I'm going to be tempted to square root this. What is the square root of a squared? It just goes away. So that would just leave me with x plus 3. What's the square root of 4? Well, it's just 2. So maybe I'll be tempted to do this. Okay, this is bad. Don't do this, but I'm going to show you what you might be tempted to do. You can't square root little parts of things. Okay? Think of it this way. What's the square root of 4 plus 4? It's equal to the square root of 8. Is it equal to 2 plus 2? No. You can't square root individual things if you're adding and subtracting. If you're multiplying, no problem. But adding and subtracting, that goes back to some of the properties of square roots that you learned back in grade 11. But just a reminder here, because you might be tempted when you get stuck or you're a little bit unsure of what to do, that is when we make up the most new math possible. It's like, I don't know what to do, maybe I'll do this, and then maybe I'll do this. And that's where we run into some problems. Okay, so this is a parabola that's opening up. And we get a very interesting looking graph in the end. Now we have a parabola that's opening down. Yes?
So you say it's just like square root of x squared times
Square root of x squared will just be a line. It'll just be x. Well, it'll be the absolute value of x, actually. But we won't get into those. Yeah. Okay. Second example. Do we have any points where the original graph is 0 and 1? Yes. We'll go back to blue. There it's 0. If we go across at 1, sure enough, we can label the points where it's 0 and 1. Do we have any nice points? Yes. This one's really nice. It's at 9. Square root of 9 will be 3. The one at 4, you could add it in if you'd like. Can you see that the y value on the red graph is 4 there? So if you went straight down from that, that's where the blue graph would be 2. Where the y value is 4. Any time where our graph is between 0 and 1 will be slightly above. Any time where the y values are bigger than 1, it's going to be below. So the below part is always easier. Can you see that that section of the blue graph is below the red graph for the y values? And this one, again, it's going to be very hard to show that section above, but you just do the best that you can. Our domain for this one, in set notation, it's between -3 and 3. So in set notation, we would write it like that. In interval notation, we would write between 3 and 3 like that. And our range goes from 0 to 3. In interval notation, it would look like that. The important thing to realize is these steps that we wrote out when we did lines, find out where your points are, y is equal to 0, plot any other nice points. Between 0 and 1, your new graph is below. When your y values are bigger than 1, no, between 0 and 1, your new graph is above. And when your y values are bigger than 1, your new graph will be below. Those steps stay the same if you have a parabola. And they're going to stay the same if you have an x cubed graph or any graph. And in fact, that is how we're going to graph any square root graph. The question goes like this. This one was given to you. But if I just gave you this equation and said graph, what are we going to do? We're going to graph the inside first. What is that? It's a parabola moved, whoops. Do I have a mistake in this parabola? This should be move 3 to the right. So what do I need in there instead of a plus sign? A minus sign. So move 3 to the right, and then 4 down. So that's our equation. So we would graph the red parabola first, and then as soon as you have the graph, now you know your technique for finding the next graph. So we'll always graph the original one first, and then we'll graph our square root graph.
Are we going to have any transformations for these graphs?
Like, are we going to then take this one and go plus 3? It would be possible that they could do that. It doesn't happen very often on an exam. But what would it mean if I added a plus 3? That would be a translation 3 up, and you just take this bloop and move it up 3. But generally, if they want to test if you know how to move things up and down, they don't add it on to something else that they're testing. Okay, question for this one is number 8, and you can work on those first 2 questions right now.